So form a PDE by eliminating arbitrary constants. So this is arbitrary function and this is arbitrary constant. We have to form PDE by eliminating the functions f and g. Here we are asked to eliminate the constants a, b and b. So before doing this question, let me have a quick definitions of what are partial differential equations and how are we gonna supposed to form a partial differential equation. Okay, so it's nothing but if you have an ordinary differential equations, you will have dy by dx, suppose, plus y is equal to 1. So here with respect to x, you are differentiating y. So x is independent variable and y is dependent variable. Y depends on x. In ordinary differential equations, you will have only one independent variable, whereas in partial differential equations, you will have more than one independent variable, that is x and y. Suppose you have z is a function of x and y, and when you are derivating z, you have two independent variables and z depends on these two independent variables. When these variable changes, your z change. So in that case, you use a new notation or a symbol, dou z by dou x and dou z by dou y, and throughout this partial differential equation we have dou x by dou y is equal to p, and for our convenience, right, is equal to q. Now let's solve the question. So first let me solve this problem, that is ax plus by plus ab. So we have two independent variables, x and y. So I'm going to differentiate z partially with respect to x and then y. So if you differentiate with respect to x, what are you supposed to get? Dou z by dou x, that is, I said, is p. Okay, that is equal to, if you differentiate this, you will get a and 0 plus 0. So p here is a, and if you differentiate with respect to y, this is your q, no? So you found the values of the constants a and b, and if you substitute in the equations, this is your required partial differential equation. Okay, now let's solve this problem. Okay, z is equal to f of x plus it plus g of x minus it, right? Now differentiate partially with respect to x. What are you going to get? Here you have f is a function of x and t, that is z is a function of x and t. So you have to differentiate with respect to x, that is dou z by dou x. I'm going to use this as p, and dou z by dou t. Here your independent variable is t, not y. Okay, so that is equal to q. Now if you differentiate this with partially x, you're going to get, let me have this as p. Okay, f dash of x plus it plus g dash of x minus it, and again if you differentiate with respect to t, you're going to get f dash x plus it into I plus g dash x minus it into minus I. So now if you compare, or if you're going to get any relations out of this and this, if you take I as common, you're going to get f dash of x minus g dash, but here you have plus. Okay, so what I'm going to do is, differentiate, this is your 1 and this is 2, 1 partially again with respect to x. So that is dou square z by dou x square. That is going to be and again this dou square z by dou t square, that is going to be f double dash I square, that is minus 1. Again minus I square is also minus 1, so g double dash of x minus it. So that is nothing but, if you take minus as common, f double dash of x, that is nothing but your dou square z by dou x square. So dou square z by dou t square is equal to minus dou square z by dou x square, that is plus dou square z by dou x square equal to 0. So this is your required partial differential equation. In this case your partial differential equation is of second order. It depends on, it does not depend on the number of functions or number of constants. It depends on how many times we are going to derivate it and make it as convenient as we want. You don't want any functions in your differential equations or any constants in there. Now the next question is f of x plus y plus z and f of x square plus y square plus z square. So this equation is of the form f of u comma v is equal to 0. This is second type. Okay, so f of u comma v is equal to 0, where your u is x plus y plus z and v is x square plus y square plus z square. Okay, now in this case your partial differential equation can be explicitly given as pp plus qq is equal to r. Okay, so you have to find the value of p, q, r with the help of u and v, that is p is equal to dou u comma v by dou. In this case you just take p is equal to dou q by dou y of y comma z and q this and all this, and just find the Jacobian matrix and just substitute in this formula to get your partial differential equation when your given equation is of f of some u comma v is equal to 0. So this is the formula to find your PDE. So I remember this as like p, q, r. So you start from r, okay, x, y, y, z and zx. So your corresponding Jacobian matrix will be like that. So it is a easy way of like remembering the formula. Thank you.